Greetings, ladies and gentlemen, and welcome to video 2 on lesson 1.3, subtracting integers. And we learned in our first video that when we subtract integers, we actually change it from subtraction to addition by the inverse or the opposite. So we add the inverse, we add the opposite. And how do we do that? We use that little catchphrase, same, change, change. Well, now in this second video, we're going to be looking at what happens if we have more than two subtrahends. Please remember, the terms in a subtraction problem are called subtrahends, where the terms in an addition problem are called add-ins. In a subtraction problem, they're called subtrahends. So you just have to recognize that every time you see subtraction, you got to change it to addition by the inverse, by the opposite. So in this particular case, number 7, evaluating this expression, negative 9 minus 16 minus 8. We're still going to use our same change. However, there's another subtraction problem, so we're going to go change. We don't need another same. We just keep changing when there's a subtraction problem to addition, with the next term being the opposite or inverse. If there is an addition part in there, if we had subtraction and addition intermixed, then we would deal with that just a tiny bit differently, and we'll look at that when we get to 1. But right now, we have negative 9 minus 16 minus 8, and we're going to same change. So it would look something like this. Negative 9 plus a negative 16. So negative 9 stays the same. Subtraction goes to addition. That positive 16 becomes a negative 16. And then we're going to change the next subtraction to addition, and that positive 8 becomes a negative 8. Now when I'm looking at this problem, I see that we're adding, because that's what we did. We changed it all to addition. And we recognize that we're adding. Our add-ins are the same sign. They're all negative, same sign, add and keep. So we're just going to add these three numbers together. 9 and 16 is 25, and 8 is 33. And since they're all negative, the answer is negative. So we have negative 33. Go ahead and pause the video, copy that down, and join me on the next example. Example number 8, 15 minus a negative 20 minus 20. So pretty darn similar to what we just did. And we're going to change to addition by the inverse using same change. And then we see another subtraction, so it's change. Every time there's subtraction, we change it to addition by the inverse or opposite. And we rewrite our problem, 15. Then it's plus, because we changed our first subtraction to addition. Our negative 20 becomes a positive 20. And then we are changing the next subtraction to addition, and that last positive 20 becomes a negative 20. Now in this particular case, I happen to recognize it really doesn't matter. Remember, the commutative property of addition says it does not matter what order you add these add-ins together. You'll get the same answer. And I usually, when I'm adding and I see opposite signs, I look for the terms that have the same sign. Usually. In this particular case, I do happen to recognize that I have two opposites. Absolute opposites. They are inverse of each other, a 20 and a negative 20, and that would make 0. So now I have 15 plus 0, and that would equal 15. Obviously, if you added the two positives, the 15 and 20 got 35, and then you did the adding of opposites where you subtract. 35 minus 20 would give you 15, with the 35 being bigger, so the answer would be positive. All right? Either way, you're always going to get the right answer if you're following the steps and the rules. Ladies and gentlemen, math is all about rules. Here we go. Next example, number 9. So we have negative 11 minus a negative 5 plus 8 minus 3. So in this particular case, we have 3 subtrahends and an add-in. Now, there is subtraction. So every time we see subtraction, we have to change to addition by the inverse. So we're going to use same change. However, we're adding the 8, so we don't need to do anything with it. If you want to, you can write same if you want. You can write same, because then when we see that subtraction, it's change. Either way, every time you see addition, you would write same. The first term is always the same. the first term is always the same. So in this particular case, we rewrite our math sentence. We would have negative 11. Changing that subtraction to addition, the negative 5 becomes positive 5. And then we would keep adding the 8. And then we would change that last subtraction to addition and that positive 3 to a negative 3. And now, going back to what I talked about in the previous problem, here I look and I see I've got a bunch of add-ins, and there's some with the same signs, the negative 11 and the negative 3. So if I add that together, same sign, add and keep, I get negative 14. And then I have the positive 5 and the positive 8, and I would get 13. And that is a positive 13, so we're going to put that positive in front of them. And now I have negative 14 plus 13. They are opposite signs. So I'm going to subtract, and I know that 14 minus 13 is 1. The 14 is bigger. It's negative. So my final answer would be negative 1. Go ahead and write that one down and join me on our last example. It is a real-life application, and it says, which continent has a greater range of elevation? So let's remind ourselves back from elementary. Range means the difference between the high and the low. And how do we find difference? That's right. We are going to subtract. So difference means subtract. So we're going to try to find the continent that has the greater range and elevation, the difference between the high and the low. And in this particular case, we are going to use the high number and subtract the low number. It makes no sense that a range would be negative. You cannot have a negative range. Range is always going to be positive. Okay? Range is always going to be positive. So we take the high minus the low. So in this particular case, I'm going to start with South America. And I'm going to say 6,960. Since we're finding the difference because it's the range, we're going to subtract, and we're going to subtract that negative 40. So if we draw a model of this, here's the continent. So we have sea level, and we have this mountain range that obviously goes up 6,960. And then there's obviously some land that is below sea level. There's land that's below sea level. You think, well, how can that be? It'd be underwater. Well, if there's a mountain in front of it, and then that mountain has a valley over here, it could go down 40 feet from sea level. All right, so that's where they get the negative. So now we're going to use our rules, same change, because we're subtracting, and we get 6,960 plus 40. We add those together. They're the same signs, same sign, add and keep, and we get 7,000 for the range of South America. Then we're going to go to Europe. And in Europe, we have 5,642 minus a negative 92. We are subtracting because we're finding range. And we're going to use same change for this one. And we're going to get 5,642 plus 92. And when we add those two together, we get 5,734 for the range there. So obviously, 7,000 is greater than 5,734, which means the elevation of South America is greater, the range in elevations of South America is greater than the range of elevations for Europe. So South America has the greater range of elevation. Ladies and gentlemen, that concludes our video notes for tonight. Your last quick write, writing a complete sentence in your own words to explain why 20 and negative 20 are additive inverse. And so I didn't use that word additive yet, but I did use the word inverse. And so we'll talk about that in class. I just want you to give it a shot. What do you think? And then, of course, you have one last problem to do. But please remember, write down any questions that you have regarding subtracting integers. You can put a question mark in your notes. You can highlight your notes, whatever it takes that you feel you need more support from Mr. Ross, make sure you come to class with those questions. Asking questions is key. If you have a question, I guarantee you someone else does. And if no one is brave enough and risking to ask it, then everyone goes without it being answered. Obviously, you can begin your work if you want, working up to a maximum of 45 minutes if you feel like getting started, because always doing questions from the book might generate questions to ask of me. Please use your time effectively and efficiently and be accountable for what you're doing. Ladies and gentlemen, thank you so much for your time tonight. We'll see you tomorrow.